MS Ramaya University of Applied Sciences.
Hi viewers, let us have a discussion on analysis of mechanisms. Before understanding the purpose of analysis of mechanisms, let us observe few mechanical systems such as automobile wiper system, quick return motion system of shaper machine, automobile suspension system, robotic manipulators, IC engines, etc. In all these systems, why do you think the elements of these machines move? The elements move because of forces and motions which are prescribed on it for achieving a desired function. The relative movement of the elements in a prescribed manner is known as mechanism. For example, an automobile wiper system may be considered as a mechanism having different links. In this system, rotary motions are prescribed at joints A and B to achieve the oscillations of wipers through rocker or coupler links. Here, inputs such as motor rotations and corresponding outputs such as wiper oscillations are controlled by adjusting the rocker or coupler link lengths. Let us look at another example, a locomotive steam engine. In this machine, power is transmitted from engine cylinder to drive wheels through 4-bar linkage mechanism, as shown in the illustration. Here, it is important to understand that a mechanism is a part of a machine, whereas a mechanism alone cannot be a machine. This is because a mechanism is meant to transfer motions, but not to perform independent tasks. Another simple and widely seen mechanism is a 4-bar door damper mechanism. In this mechanism, the objective is to quickly move link 4 due to the prescribed motions on links 2 and 3, as well as by grounding the first link. Here, the kinematic analysis is required to arrive at lengths of links 2 and 3 for achieving the desired motion of link 4. Based on the previous examples, let us try to find why kinematic analysis is required. The objective of kinematic analysis is to know the motion and the design requirements. Motion requirements are position, velocity and acceleration of different links in a mechanism at different times. Design requirements are shapes and sizes of different links in a mechanism. This serves as a basis for dynamic analysis of a mechanism. Dynamic analysis helps us to arrive at load distributions and motor or actuator requirements at each joint of the mechanism. Summarizing all these discussions, we understood that any mechanical system is composed of links, joints and forces. The mechanical system should change its configuration with respect to time in doing the required task. Hence, the objective of any kinematic analysis is to determine the position, velocity and accelerations of different links of mechanism to control and achieve the desired functional output. In order to perform an experiment with respect to kinematics of mechanism, we will work with 3 simple mechanisms. First, 4-bar linkage mechanism. Second, slider crank mechanism. And third, Scotch yoke mechanism. First one is kinematic analysis of 4-bar linkage mechanism. It consists of 4 links. AD is input link or crank. BC is output link or crank. The objective of this mechanism is to transfer the rotations of input crank to output crank through rocker or coupler ECD, as shown in animation. If kinematic analysis is conducted for this mechanism, the position, velocity and accelerations of the coupler link and the output link can be studied relative to the input link. Degree of freedom indicates the number of independent variables required to completely define all the positions in a mechanism. Using number of links and joints, the degree of freedom of any mechanism can be predicted by Gabler condition. If degree of freedom is found as 0, the mechanism is considered as a structure. Grashoff's condition is used to predict the rotatability of the mechanism. As per Grashoff, the sum of the shortest and longest link lengths should be less than or equal to the sum of remaining 2 link lengths. If this condition is violated, then the 4-bar mechanism cannot rotate. Hence, these conditions are always essential to validate the mechanisms. The applications of 4-bar mechanism in everyday life. An existing 4-bar mechanism model in relevance to locomotive coupling, steering gear system and beam engine is as shown in the image.
Hi viewers, let us understand the purpose of kinematic analysis of 4-bar link mechanisms. So in any 4-bar link mechanisms, we should have at least 4 links. Here, if we see one of the 4-bar link mechanism, the first link is grounded, the second link is crank or input link, the third one is connecting rod, the fourth one is rocker or output link. So if I fix any one of the links of this mechanism, I can get the inversions of 4-bar link mechanisms. So in this case, if I give input at the crank, input crank, that means I am trying to give one complete rotations at the input link so that I can get an oscillations at the output link. This mechanism is mostly used in beam engine applications. One more applications of 4-bar mechanism is Ackermann steering gear system, in which these two are crank and rockers which are of equal lengths. If we try to give input to the coupler link, so this is how we can give an input to the coupler link, so that we can expect equal angular rotations at both the cranks. This type of mechanism is used in automobile steering systems. Another application of 4-bar mechanism is in locomotive coupling system, in which we can see the input link here. This is called input link and these two are output links. If we try to give an input to the input link, the output links also gets synchronized with the input link. So this type of mechanism is used in locomotive coupling systems. Here the speeds of input and output links are same.
3, 2, 1, go.
This type of mechanism is used in locomotive coupling system. Here the speeds of input and output links are synchronized.
In order to study the kinematics of 4-bar mechanism, rotate the input crank in steps of 30 degrees and measure the angular displacements of output link and coupler links for every 30 degrees. Plot the displacements of coupler link and output link versus the input crank angles. This helps to visualize the effect of input link motions on output link and coupler link motions. If output link and coupler link motions are to be changed, then the length of the links can be changed and analyzed further for desired motions.
At MSR UAS, we spark your imagination unlike any other.